In this video, we're going to be practicing our polar coordinates and working on AP Pre-Cal Homework 10-1. So we're going to start by just kind of plotting approximate locations of the polar coordinates and in the plane. And so if these are polar coordinates, remember, I think the important thing here would be for me to remind you that it's r and then theta. Okay? And so in this case, r equals 3, theta equals pi over 2. Okay, so along the ray pi over 2, which is here, the thing I drew in blue, I'm going to go forward 3 units, and so that will be point A right there. Okay. For B, 1 and pi, that means radius is 1 along theta equals pi. Well, we know theta equals pi is over in that direction, and if we went 1 unit forward in that direction, because it's positive 1, then we would be at that spot right there, and I'll just label that one B. Okay, with C, 2 units from the origin along 5 pi over 4. Okay, well, 5 pi over 4, that's bigger than pi, and it's a pi over 4, so it's going to be along that way. If that's a 45-degree angle, and it's at just approximate location, so that'll be fine. And then we're going to go 2 units away, which would probably be about there, and I'll call that point C. Right. Point D, half a unit away from the origin along 4 pi over 3. Okay, that's not a very straight y-axis, but it'll be all right. All right, 4 pi over 3 is bigger than pi by pi over 3. Okay, so we're going that direction forward half of a unit. So I guess maybe I'll just mark that as 1 unit away, and then half a unit would be there. Okay. Let's see, all right, the next one's over here. Negative 2 along pi over 6. Okay, so I'm going to draw pi over 6. Okay, pi over 6 is a 30-degree reference angle. All right, so we're going to go towards that blue arrow, negative 2 units. So we're going to go back by 2. Maybe I'll try to extend that with a dotted line. That was really not very good. Oh, I'm going to try to pause it and make it better. Let's see if I can, I can make that happen. All right, so that's a little better. We'll say the thin part of that blue line, that's the part of theta equals pi over 6 where r is negative, right? We're going to go backwards 2 units, so I'm going to mark off what I think is 2 units of distance, and that will be point E. All right, for F, r equals pi over 3 and theta equals 3. This is, I was waiting for one of these. Okay, so that's what we got to be careful about. Okay, pi over 3 units from the origin along the ray theta equals 3. Okay, that's theta equals 3 radians. That's a little bit short of pi because pi is 3.14 radians. Okay, so that means 3 radians is going to be, I don't know, probably about like that. And then pi over 3 units away, well, that's going to be tough. That's about 1. We just decide whatever we think pi over 3 is. And then I might add in a little, distance marker. That was not very parallel, but I think you see what I'm saying here. That distance there is pi divided by 3. Now we're going to find two additional representations of the given polar coordinate, one having a negative r value on the interval 0 to 2 pi, and another having a positive r value and a negative angle. Okay, so to get the negative angle, I think that'll be the easiest one first. We just subtract 2 pi from theta. Okay, so 2 and 7 pi over 4, I'm just going to say, all right, maybe I'll do the one with the negative angle first, and so that would be r equals 2, theta equals 7 pi over 4. Well, that's almost all the way to 2 pi. That's the same as negative pi over 4. Or you could think about 7 pi over 4 minus 8 pi over 4 is negative pi over 4. Either way, you're going to get negative pi over 4. Okay, so that's one with a negative angle. And then you can't really see it, but I'm going to do negative radius in blue. And I think for that one, it might be helpful to... okay. On one hand, you could say, okay, across the circle is going to be adding pi or subtracting pi, but since I'm over here close to 2 pi, I should probably subtract pi to get that spot across the circle, and subtracting pi is minus 4 pi over 4. That's going to be 3 pi divided by 4. Okay, that's one option you've got. But the other option would be to kind of sketch what's going on here. Oh boy. All right, yeah. If we're going along 7 pi over 4, we just would have to be thinking what's kind of like across the circle from that. And the dotted line, that's 3 pi over 4. Okay, so 2 and 3 pi over 4, and, oh wait, negative 2 along 3 pi over 4. Yeah, because then that would take us down into the fourth quadrant. Okay, let's keep it going. For B, 2 and 5 pi over 3. Okay, so the first one, I'm going to get a negative angle and a positive radius. So r equals 2. Theta equals 5 pi over 3 minus 2 pi. Minus 6 pi over 3, that's negative pi over 3. And then as far as the one where r is negative, okay, r will be negative 2. And we'll just go across the circle by subtracting pi. So 5 pi over 3 minus 3 pi over 3 is going to be 2 pi over 3. Okay, if I've drawn the diagram and thought about, what's... I should start with the circle usually. Oh, that's fine. 5 pi over 3, that's right down here. So the opposite one up here would be right there. That's 2 pi over 3. However you want to do it, it's fine. Okay, for C, r equals 1, theta equals pi over 2. Okay, if I wanted to write that with a positive r value and a negative theta value, I'm going to take pi over 2 and subtract 2 pi. So 1 pi over 2 minus 4 pi over 2, that's negative 3 pi over 2. And then the one with the negative radius, well, that'll be negative 1. And, thinking about what's opposite pi over 2, okay, I guess that works. It would be 3 pi over 2. So negative 1 units down towards 3 pi over 2 would leave me up above the x-axis. So that would be positive 3 pi divided by 2. All right, one more of these. We're going to, for positive radius, keep that 7. Subtract 2 pi. We already did one of these. Okay, and then negative 7. And the one across from 5 pi over 3 was 2 pi over 3. Okay, I think 3 unique ones is plenty for this problem type. I'm not going to go back in and change the problem or anything. Okay. So given rectangular coordinates, find 2 polar coordinates that fit the points. Okay, now my advice on this type is if you're given rectangular, sketch the graph, or sketch, not the graph, but I guess sketch the point in the plane and let that tell you what theta is, and then figure out r with the formula. Okay, so the formula we need is going to be r squared equals x squared plus y squared. Okay. So if I'm graphing this thing where x is positive and y is negative, I'm really only going to need the fourth quadrant. 3 root 2 and negative 3 root 2, those are the same number, just one's negative. And so that means I'm sitting on a 45, 45, 90 triangle. Okay. That also means that this ray I just drew here, that's going to be negative pi over 4. So if I'm 2 polar coordinates, okay, I like to think of this as negative pi over 4, but I know y'all think of it as 7 pi over 4, so there we go. Those 2 coordinates. We just have to figure out r. So r squared equals x squared. Well, if I square 3 root 2, I'm going to get 9 times 2. Plus, if I square negative 3 root 2, I'm going to get another 9 times 2, and it will be positive because negative times negative is positive. And so 18 and 18 is 36. R squared equals 36. Let's just go with r equals 6. And then, all right, so r equals 6. Theta equals negative pi over 4. And then also r equals 6. We could just call that same theta spot 7 pi over 4, and we'd be happy, and we can move on. Okay, with 2 root 3 and negative 2, if we see a square root of 3, we know that's a 30, 60, 90 triangle. So, x is positive, y is negative. Yeah, I want that same fourth quadrant. Okay, 2 root 3 is going to be a bigger number than 2 because the square root of 3 is greater than 1. And so that means I'm going to go farther to the right than I am going down to get to this point here. And maybe that's a little out of scale, but out of scale is good for us, especially with 30, 60, 90 triangles, because it makes it really obvious if it's 30, 60, 90 or 60, 30, 90. Okay. Go through here. This is looking like it's short of, oh man, that was tough. That's not what I wanted either. Okay, that's got to go. All right, let's just try that once again. Okay, that'll do. And that looks like a 30-degree reference angle to me. So I could say that theta is negative pi over 6, or I could say it's 11 pi over 6. Either way. And that sounds like a good way to write 2 polar coordinates. Okay, I will need r. r squared equals x squared, that's 4 times 3, plus y squared would be just negative 2 times negative 2 is positive 4. And they'll have 12 and 4 is 16. Okay, that means that r is either 4 or negative 4, but since I've already got two different theta values that correspond to this point, I'm going to say r equals 4, theta is negative pi over 6, and then the other one is 4 and 11 pi over 6. But maybe with the next couple, if I'm not in the fourth quadrant, I might, do this with a negative r value, because we need to be practicing that as well. All right, so r equals no, this is an x and y. X equals negative 5, y equals 5 root 3. Okay. Negative 5. Oh, okay, I think that's, 5 root 3 is the bigger number, so I'm going to give myself room to express that. And, I feel like I could be even more exaggerated with that, so I'm going to. I'm going to say, all right, negative 5 is going to be right here, so that when I plot this point, it's more obvious that I'm sitting on a 60-degree reference angle. I know it's either 30 or 60 because that's square root of 3. So we're going to give ourselves a ray there. That looks like theta equals 2 pi over 3 to me. And so I'll say, okay, I need to find r. R squared equals x squared plus y squared. If I square 5 root 3, I get 25 times 3, which is 75. So if I add 75 to 25, I'm going to get r squared equals 100, and then r equals 10. Okay, and so two polar coordinates would be r equals 10, theta equals 2 pi over 3. But if we needed to have, for some reason, if we wanted to express this as a polar coordinate with a negative r value, we'd say r was negative 10 along, what is that? That looks like negative pi over 3, but we could also call it 5 pi over 3. With negative root 3 and negative 1, that's in the third quadrant, both x and y are negative, negative root 3 and negative 1. Oh, right, so that's looking like a 30-degree reference angle. Beyond pi, that would be pi plus pi over 6 is 7 pi over 6. And, okay, what was I thinking about that? Okay, theta equals 7 pi over 6. I'm going to just write that. Okay, and then I need to find the radius, the r value. R equals x squared plus r squared equals x squared plus y squared, and that's 4, so that means to me that r is going to equal 2, or possibly negative 2, and I think I'm going to do that. So I could have r equals 2 along theta equals 7 pi over 6, and then theta equals... That looks like regular pi over 6. Yeah, and that makes sense because if I subtract pi from 7 pi over 6, look all the way across the circle, I'm going to be sitting on pi divided by 6. And that would be where r was negative, right? Because I am in the third quadrant where x and y are both negative. And so if I'm thinking about pi over 6, I need to be going backwards, and that's where we get that negative r value. Okay, with e, 4 and 4, okay, if we have, equal x's and y's, it's got to be a pi over 4. Because we're going to have opposite and adjacent legs being equal. That makes it, yeah, if the two legs are equal, that makes it an isosceles triangle, and an isosceles right, that's 45, 45, 90. I was like, wait, what was the... I remember we had some sort of logic in there. And so here's a 4, and that's a 4. So I think that y'all are probably good knowing that this is theta equals pi over 4. I think the trap would be to think that r was also equal to 4. Okay, because it's 4 and 4, why wouldn't it be? But r squared equals x squared plus y squared. And so r squared is 32, which is just 2 times 16. So r is going to be the square root of 16 times the square root of 2. That'd be 4 root 2. And if you know about the x root 2 pattern, go ahead and use it, right? But if you don't, we can just work with the formula that we already know, which I guarantee we all know the Pythagorean theorem formula. So that's just what I'm going to be showing here. Okay, 4 root 2 along theta equals pi over 4. But if I wanted to write this with a negative radius, I'd be over here, and that's not quite a straight line, but I think you get what I'm saying. It's 45 degrees in the third angle. I mean, third quadrant, that's going to be a reference angle, or pardon me, a angle of 5 pi over 4. I don't know, struggling on that one. Okay, so in that direction, r is going to need to be negative. So negative 4 square root of 2. I think we got one more of these. Negative 3 and 0. So x is negative 3, y is 0. Okay, so I could say that's 3 units away towards theta equals pi, so that'd be positive. But I could also say that, that's like negative 3 units along theta equals 0 or 2 pi. So I might just leave it like that. Okay, that was, enough of that. Given the polar coordinates, find the rectangular coordinates. This is the one where I do recommend you use the formulas, especially for the situations where r is negative, right? You can go in and draw triangles and use the trigonometry skills that we built up in this course, but I think that at this point, like, you know how to find cosine theta and sine theta, so just use r cosine theta, r sine theta. So x equals r cosine theta, and y equals r sine theta. I was going to write that in blue. Okay, and then we've got, an r theta pairing, so I should be able to just use the formula and figure this out. All right, so x equals 1 times the cosine of 2 pi over 3, and y is going to equal 1 times the sine of 2 pi over 3. Okay, then I'm going to draw a trig diagram for 2 pi over 3. All right. Okay, so negative 1/2 root 3 over 2. Okay, and so 1 times cosine of 2 pi over 3 is 1 times negative 1/2 equals negative 1/2. And then 1 times the sine of 2 pi over 3, that's root 3 over 2. And what was I thinking about this one? Oh, because r was equal to 1. I mean, it's really the same, just like kind of drawing the standard triangle and then scaling it up by some amount when they give you r. But when r is negative, I don't like to think about scaling a triangle by a negative number and seeing it move. Don't love that. So if I might start with the diagram for 5 pi over 6. Ooh. Well, that'll be all right. So that's going to be a half. The longer leg is root 3 over 2, and the hypotenuse is 1. That's going to need to be negative because I'm in the second quadrant. And so, all right, x equals 4 cosine of 5 pi over 6. And that would be 4 times negative root 3 over 2, and that's going to be negative 4 square root of 3. And then y is equal to r sine theta. And that's 4 times a half, which is going to be 2. And I didn't do this one on the other one, but I think you'd be all right. We can list these as x, y coordinates that way. All right, so that was B. All right, let's see. Okay, this is just going to keep going. Need to be patient. So r equals 5, theta equals 7 pi over 4. Let's just draw a little trig diagram for 7 pi over 4. Okay, this one will be negative. Hypotenuse is going to be 1. All right, so x is 5 cosine of 7 pi over 4, which is 5 times negative, wait, no, positive root 2 over 2, because cosine is the horizontal component, horizontal leg. And so 5 root 2 over 2. And then y is going to equal r sine theta. Okay, and sine of 7 pi over 4, that's negative root 2 over 2. So 5 times negative root 2 over 2, that's going to be negative 5 root 2 over 2. And D, here we are, 6 and 4 pi over 3. 4 pi over 3 is in the third quadrant, just a little bit beyond pi by pi over 3. All right, so that'll be negative 1 over 2. That would be negative square root of 3 divided by 2, and that'll be 1. Okay, so our cosine theta. Okay, so 6 times negative a half is negative 3. And then y is going to equal our sine theta, which is going to be 6 times negative root 3 over 2. I divide the 6 in half, and that'd be 3, so negative 3 square root of 3. If I want to write these as a coordinate, I'd say negative 3 and negative 3 square root 3. Let's see, all right. 2 and 7 pi over 6. I'm just going to keep doing the same old thing. Drawing my trig diagrams, using my formulas, obtaining answers. So 30, 60, 90, that's going to be the half. This will be the root 3 over 2. That's probably out of your field of view. And then this will be 1. So I'm thinking x is our cosine theta. And cosine is negative root 3 over 2, so 2 times negative root 3 over 2. Well, I'll just cancel off the 2's. And I get negative square root of 3. And then y is going to be 2 times the sine of 7 pi over 6, which is 2 times negative a half, which is negative 1. Okay, and so if I was going to write these as a coordinate pair, negative root 3 and negative 1. All right. Negative 5 and pi over 4. Okay, so pi over 4. Okay, 1 root 2 over 2 root 2 over 2. And let's see, what was I thinking about that? Oh, yeah. And this is exactly the thing. I don't want to think about scaling this by negative 5 and like trying to pivot it over the origin or anything like that. I'm just going to use this triangle to determine cosine of pi over 4 and sine of pi over 4. And I'll let the fact that r is negative multiply x and y by negative 1, or like multiply by negative numbers, so it makes it negative. Takes care of it for us. That's why I like using the formula. X equals r cosine theta, which I guess I'd kind of been writing more explicitly, so like negative 5 cosine pi over 4, which is going to be negative 5 times root 2 over 2. Then y is going to be equal to negative 5 times the sine of pi over 4, which is the same thing, so I should get the same result. Yeah, negative 5 root 2 divided by 2. And so if I was going to write these, negative 5 square root 2 divided by 2 and negative 5 square root 2 divided by 2. Okay, is that all of them? No, it's not. Oh boy, this one just keeps going. Let's see how long this one is. Okay, not too long. I'm just got on the second to last page here. So r equals 4, theta equals pi over 2. This one, if it's one of the extremes, like 0, pi over 2, pi, or 3 pi over 2, I'm just going to draw the picture. I don't need the formula for that, right? 4 units away along theta equals pi over 2, that's x is equal to 0 and y is equal to 4. We can solve that with our eyes, okay? At least if we draw a picture, but I think I've probably got a lot of students that are just going to visualize that, not actually draw it down on a sheet of paper, but visualize that and be like, oh, okay, x is 0, y is 4. And if you can do that, good for you. And if you want to draw the diagram or just use the formulas, you're welcome to do that, right? Like I always say, do it however you're going to do it. Just make sure you're right. So h is negative 5 units along theta equals pi. Theta equals pi. Again, I think we can do this without going into the formulas. Okay, theta equals pi is going off to the left there. And then I'm thinking negative 5 units along theta equals pi, I'm going to go over here, 5 units away from the origin to the right, that's what I was trying to say, and where x is 5 and y is 0. Okay, so those were two nice ones to end with. After the given rotation, okay, now this is something we didn't really talk about in the notes, but this is not going to be hard. Hope I'm not letting you down. But it's really not going to be that big of a deal because, let me think how I'm going to write this. I'm going to, I'll come back with something. All right, there you go. That's what I'm thinking about. So if we're rotating clockwise, that's backwards on the unit circle. So we're going to need to subtract some angle. But really, like if we're just rotating, that's not going to affect r. Okay, it's not going to affect the distance from the origin if we're rotating along a given circle. And if we're rotating by alpha radians, if we're going clockwise, let's just subtract that. If we're going counterclockwise, we're just going to add that. Okay, so thinking about this one over here, pi over 2 clockwise, that's going backwards by pi over 2. So I'm going to say, all right, r equals 1, and theta equals 2 pi over 3 minus pi over 2. So that would be going into pi's over 6. That would be 4 pi over 6 minus 3 pi over 6, and that's equal to 1 pi over 6. Did this ask for the rectangular coordinates of the point? Okay, r equals 1, theta equals pi over 6. Okay, that'll actually be pretty easy because if I just draw the standard triangle, the reference triangle, that's going to be having distance 1 from the origin. So I'd say, all right, pi over 6, that's supposed to be a shorter triangle. I mean, it's not 45, 45, 90, but I'd like to draw them a little shorter than that. So x is going to be root 3 over 2, and y is going to be a half. Let's see, what's the next one? Okay, b after a rotation pi over 3 clockwise. We're going to subtract pi over 3 from the angle. Okay, so we're going to be saying, stylize that. Okay, so I said r equals 4, and theta is going to be 5 pi over 6 minus pi over 3 is 2 pi over 6, and that would be 3 pi over 6. Oh, we like that. That's pi over 2. Okay, so if r is 4 and theta is pi over 2, I'm just going to draw a diagram. Let's say, okay, I'm going up 4 units along pi over 2, so that's going to be where x is 0 and y is 4. Okay, pi over 2 counterclockwise. And let's see, counterclockwise, we're going to add theta, or add pi over 2 to whatever our original theta was. So that's going to be r equaling 5 and theta equaling 7 pi over 4 plus pi over 2 is 2 pi over 4. That would be 9 pi over 4. And you're like, oh, 9 pi over 4, that's not a number I know. But that's just a little bit bigger than 2 pi by pi over 4, so this is coterminal to regular pi over 4. So I'm going to say, all right. And maybe this time I'll do it with a triangle method. Okay, we've got pi over 4 here, 9 pi over 4 now. And we're going to say, all right, well, originally it was 1 and root 2 over 2 and root 2 over 2. But now I'm scaling this up by a factor of 5. So my x and y coordinates will be 5 root 2 over 2 and 5 root 2 over 2. I feel like we've had one similar to that. Oh, it was negative 5 and negative 5 root 2. Okay. So d after rotation pi over 2 counterclockwise. All right. Okay, so we've got r equaling 6, and then theta equaling 4 pi over 3. And then I'm going to add, I need to take that into 8 pi over 6. And then pi over 2 is 3 pi over 6, and that's going to be 11 pi over 6, which is something I know about. So that's a good sign. And we're going to say, all right, 6 and 4 pi over 3. Oh, no, 6 and 11 pi over 6. All right. So 11 pi over 6, almost all the way to 2 pi. Ooh. I wasn't sure I was going to come back with a line. Okay, so that's going to be negative 1 over 2, positive square root of 3 over 2, and 1. But if I want this to have radius 6, I'm going to multiply all 3 sides by 6, and I would get my coordinates being x is 6 over 2 is 3, and negative half of 6 is negative 3. That's how we would get those coordinates. All right, now on to the last page in the complex number discussion. So, given complex number in the form a plus bi, express the complex number in the polar form where r and theta, wonder if we cut off that sentence somewhere. But we're just going to find r and theta, and we're just going to kind of leave it like in terms of, 4 root 2 cosine and sine of pi over 4. So 4 plus 4i. Okay, well, that's going to be the imaginary axis. This will be the real number line. And if we're going to 4 plus 4i, that'll be right here. That looks like theta equals pi over 4. And just like before, we think about the legs of the triangle, squaring them, adding them together to get r squared. So in this case, theta equals pi over 4. And r squared equals 4 squared plus, and we're not going to take 4i and square it because it's the length of the leg. If I was to turn this into a triangle, the length of the leg, the vertical leg would be 4, and the length of the horizontal leg would also be 4. So that's going to be the square root of 32, which we have already reduced in this video, and that's, I've got it backwards, that's 4 root 2. Okay. Or r could be negative 4 root 2, but then we'd have to get a different theta value, and so it's, number A equals r cosine theta plus r sine theta multiplied by I. And we're just going to leave it like that. Seems a little wrong for AP Pre-Cal, but there's a bunch of multiple choice questions that look like this, and they kind of just stop there. So we're just going to stop there for this one particular thing. Because we know that this is not the type of object that could possibly show up on your free response, right? Because we already know what this is going to be, and it doesn't have anything to do with complex numbers. So negative 2 root 2 plus 2i root 2. That's a strange number, 2i root 2. But I see what they're saying. It's basically negative 2 root 2 on the real axis, and positive 2 root 2 on the imaginary axis. So this one's going to be another pi over 4. Looks like that's going to be 3 pi over 4. Yeah, so I'm going to say theta equals 3 pi divided by 4. And then r, I'm going to need to square some stuff. So r squared equals negative 2 root 2 squared, which would be positive 4 times 2, plus the other 2 root 2 squared, which is also going to be 4 times 2. 4 from when I square the regular 2, and 2 from when I square the square root of 2. So I'd have 8 plus 8 is 16. R squared is 16. That means r is 4, or possibly negative 4, but we'll be interested more in the situation where r is positive 4, right? But if you wanted to write it with negative 4, and then theta is 7 pi over 4 or negative pi over 4, be my guest, right? If that makes you feel better. But I'm going to just say, all right, b equals r cosine theta plus r sine theta I. Okay? Just finding r and theta, really. That's all we've been doing the whole video anyway. All right, so over here, I square root 3 and negative 1. Okay, so that's going to be a 30, 60, 90 type of situation. X is negative, y is positive, and specifically negative 1 is not as negative as square root of 3 is positive. So I'm going to just mark that there. That's going to be 2 pi over 3. So theta equals 2 pi over 3. But 1 and square root of 3 are not numbers I typically put on my 30, 60, 90 triangle, so I've got some other radius. And I'll just figure that out with the formula. R squared equals horizontal displacement squared, that would be negative 1 to the 2 is positive 1, plus square root of 3 squared, that's 3. Okay, r squared equals 4, r equals 2. That's kind of what I suspected. But I'm going to say C is r cosine theta plus r sine theta I. And then, let's see, I'm sure I've got one more here. Yeah, that's okay. And then here we go. Okay, so 3 minus 3 root 3i. Okay, so we're going to have a positive real component and a negative imaginary component. I think that's a better terminology. And so positive 3, negative 3 root 3. Okay, I'm here at negative pi over 3. And I guess I hadn't been drawing that on the other ones. So I'm going to say, all right, theta is negative pi over 3. But if you want to call that 5 pi over 3, go ahead. It's the same thing, right? And I'm going to have I'm going to need to compute r. R squared equals 3 squared plus negative 3 root 3 squared. Well, that would be 3 squared is 9 times 3, that's 27, and 9, okay, 36. Okay, so r squared equals 36, and that means r could equal 6 or negative 6, but we're just going to keep our life as easy as possible and just go with a situation where r is positive 6. So point D can be written as r cosine theta plus r sine theta multiplied by I. Okay. And now the last one, we're going to be writing an expression that represents each of the 4 points on each of these two images. And if you're looking for more guidance on like, wait, what is this problem actually getting at? I would point you towards the back of the last example in the notes for this lesson, because it's very similar to the one on the right, and it's got multiple choice answer choices that maybe could guide you in the right direction if you're wanting to try this on your own. Okay, so what I'm going to do is I'm just going to think about if we've got a blank slate and we're going to have to choose on our own, then I'm going to be saying, well, I'm thinking, I'm going to go back and look at that example. I think I did it wrong in class. Okay, no, I didn't do it wrong. There was just a little bit more subtlety to it than I'd thought. Okay, so what I'm going to do is I'm just going to like look at the first one I see. And I'm going to say on the left, the first one I'm noticing is pi over 2. Okay, so here, theta equals pi over 2. And then I think about how far are these separated from each other. Okay, and to me, it looks like they're separated by pi over 2 because it's like 90 degrees away. Pi over 2 to pi, to 3 pi over 2 to pi, back to pi over 2, or to 5 pi over 2, however you want to think about it. But I'm going to say this is pi over 2 plus pi over 2k, where k is equal to 1, 2, 3, and 4. Now, if you wanted k to equal 0, 1, 2, and 3, that'd be just as good, right? It would give you the same thing. When k equals 4, that will give me the point that's circled in red because it's pi over 2 plus 2 pi. So I get right back to where I started, and that's an equally valid theta value for that point up there, 5 pi over 2. Hey, with this one, I'm going to do the same thing. I'm going to think about this first one. That looks like pi over 4. So theta equals pi over 4 plus, and then how far is this one? Okay, we have to think rotationally. So if I go from here to there, how far did I rotate? Well, that looks like a right angle. It looks like I rotated 90 degrees. So pi over 4 plus pi over 2 times k, where k is equal to, you could do 0, 1, 2, 3, or you could do 1, 2, 3, and 4. And if you saw the example, in class, in the notes, with the multiple choice answer choices, you might understand why I'm doing k as 1, 2, 3, and 4. Okay, so I think, yep, that's going to be all for this homework. So that's all for this video. Thanks for watching.